that brings us to the last session of the day, right? Like from climate tech to agri tech, and how we are seeding innovation, and what's the deep tech's role in modern agriculture. We have with us Subrat Panda, who is the CTO of AGNXT, and he will walk us through how rapidly assessing food quality is really at the core of uh, providing more incomes to producers, farmers, improving trade, and in general improving the agri value chain. Right? Like we will learn from Subrat at AgNext on how they are leveraging advances in deep tech to improve agri value chain. So over to you, Subrat.
Thank you, Amol. Thank you, Nasscom, for this opportunity. I hope I'm audible.
Yes.
Okay, great. Um, I put on the slide, so I hope this is visible as well. So, okay. So, general introduction. What is the agri-tech? It's a you can Google, but I think anything which is improving productivity and bringing in efficiency and profitability in agriculture is in the purview of agri-tech. It involves drones, which are satellite photography, IoT based sensor networks, tracking, forecasting, weather, irrigation, automated and precise and precision irrigation, hydroponics, less water and you grow a lot of plants and food around it, soil moisture sensors, or not just moisture but chemical sensors. All these are part of agri-tech. Um, what we do at AgNext, I think we have a brief history about what we are and
And
who we are.
Subrat, just a second. So your slide has stopped. It's not visible to the audience. So if you can stop and share it again,
Okay,
so that your slides are visible.
okay. I shared my screen. Let me share my entire screen then. That's
Yeah.
it. Is it
Yeah,
visible
it's
now?
visible. Yes, it's visible now.
Okay, great. So we at Agnex, we are primarily into the core technologies that we have worked on is around NIR spectroscopy, computer vision, electrochemical sensing, IoT. And we've built solutions around them in various verticals around tea, around grains, around milk, and a lot of other sensing devices technologies, right? And then there are software and hardware solutions around them. Uh, Primarily, any technology that we have built is focusing on quality evaluation of post-harvest produce. What does that mean? Is when you procure or when a farmer is selling wheat or he's selling say brinjal or chili or anything, right? Uh, the pricing that is happening and for which is getting a price is a function of quality and quantity. Quantity is a weight thing, right? It's a very standard thing, but quantity has been a bit subjective. What we have built is to make technology which is ensuring that quality is becoming objective. It's a hard problem because it has been there is a lot of history around it. People have been doing it in specific methods, but when you bring in technology disruption, there are challenges. But yes, we have been building them and have been disrupting those value chains in grains, oilseeds, pulses, tea, and other things. Now, uh, what you require to build this technology is it's a trifecta of AI, hardware, and a lot of data collected. So, hardware means the sensor built, which is replacing the current sensing technology that is being used by human beings. Then we collect a lot of data using the sensors. This data is then used to build intelligence, which is then pushed back to the hardware, and this device is able to do things on its own. And this is how we build all our tech, right, around computer vision and an spectroscopy or chemical sensors. Um, what we do, I spoke about it. I won't, in the interest of time, I will skip this slide. One of the things that we touch around, and the previous speaker talked about sustainability, and to some extent, it's an existential question for all of us. I think what we build today is ensuring that you are building a sustainable, you're making the full value chain sustainable in the sense that Today, if you do a test, right, chemical test, there is chemicals required. There is a lot of carbon dioxide emitted to the, into the environment. These devices don't they consume very less power, and they don't need any raw materials for consumption, right? So it's like taking a photograph and finding out what the image says, or taking a spectral signature and telling what the chemical composition is. So we ensure that testing is sustainable as well, right? We don't have to. We bring the lab, a technology-oriented lab to the field. This The samples don't have to go to the lab and get tested. So um, I think what we have, the most important USP that we provide, is we enable quality instantly on the spot. Right? It's very time and cost effective. Like I said, there's function of quality and quantity. All transactions, we ensure quality is done. For example, I have given an example of wheat, chili, fruits here. Right? The chemical qualities for wheat checked are gluten, ash content, protein content, right? And there are many other things that also, for interest of time, I didn't list it down here. Then for the physical thing, you have to look at whether how many broken grains are there, how many damaged grains are there, how many wilt grains are there, how many shriveled foreign matter, live insect infestation and other stuff. Right? So how good are we on that is something that is tested using our technology. Uh, if you want to do it today, let's take what people do today, right? So for the chemical test, people take it to a lab. The samples are destroyed, tested out for the properties, and then tested. And they take around a day to complete the test. And you need a lot of raw materials, electricity, power, and other stuff like that. On the physical side, there's a person sitting who would be taking those grains after post sampling, and then divide, or rather examining them, every grain, with his eyes, and then segregating it. And once segregation is done, weigh the samples according to the classes identified, and give the percentage weight. So this is how it is done today. Compare this, and that's typically a hour to a hour and a half process, long process. You bring it down to 5 minutes, both those tests, right? And you can bring this test. You don't need a specialist. You take any guy. He has to just follow the SOP, put the samples in the device, and you get the results. Interesting case is that of chili. The chemical test of chili takes around you know 24 to 48 hours and costs a lot to do one sample test. Right? And it has to be done with a very high end machine, an HPLC machine. Um, and the physical ones is again, you have to find out whether there's a damage, there's a broken tape, or there's a black tape and other things like that. We have solutions for them, which can do this both the things instantly. So, what challenges do we have in agriculture? Mother nature's play. Right? There are innumerable varieties of rice, wheat. Name any. Even chili, I know is there are some 400 varieties across the world. Right? India being the largest producer of chili, and the interesting thing in a country like India is every 100 kilometers, or maybe 200 kilometers, the quality of the agricultural produce changes, because soil quality changes, the type kind of irrigation changes, the kind of water supply, the kind of the farming practices, they are different, right? So there are varieties, and even within the varieties there will be sub varieties. Right? So just look at the number of rice which is cultivated worldwide. 40,000 varieties of rice, and in India it is just 6,000 varieties of rice which is cultivated in India, across all states. Um, these are challenges which are really big scale and difficult to conquer. What the and there are few factors of success that, uh, even if you build technology for these, there has to be government policy push. There has to be ground awareness with the farmers or the FPOs that quality measurement is a good thing. Tech is a good thing. Tech helps you build better value and better pricing. And there are tech providers like us. So there has to be a top down and a bottoms up policy thing which will help us, which will help the farmers and the lower level people who are in the food chain early on, so that they get realize better value for their produce. This is a typical slide, right, which where we cover. It's a cycle which is done in every AI product. Like, you have to get sensors, you have to collect data, you have to ingest the data, clean the data, do a model building on them, deploy, see whether you are good enough, go back, collect more data, improve the model, and do that. The cycle is there everywhere. Nothing new here. Now, take that cycle and let us look at what we do in our labs. Right? What we do, we have taken the sample, we test the sample out in the lab, we collect the reports from the lab, and this is, duplicate testing is also done here. We collect the same sample in our, in our device. We get the spectra out of it and then correlate the spectra with AI ML algorithm with the lab data collected. This typically is done over thousands and thousands of data, and you get a end of it, you get a rapid proximity analysis analyzer. The same thing happens on the computer vision side as well. You have the sample, you put the sample on the device, you get the image. You have people who are labeling experts take their data, and this is defined as per industry standards, and a lot of work is done by government. And then you do that model and build a model and put it on the device. I'll take an interesting test case, which we did for farmers in Telangana as part of Sagubagu project. Uh, the most important part was, we had to make chili quality assessment uh, available for farmers at a very scalable way. So at the procurement centers, which were primarily the FPOs, or a couple of FPOs, we built a solution and deployed them. Now, the most important part of the solution was, you have to build a good scalable hardware which could work under all lighting conditions, because these are not lab conditions. You have to have the NIR device was very standard. We had to build the moisture meter for the chili pots. They all have to be battery powered, and the AI layer was like I showed in the earlier slide. We had to build the models for all the varieties which they were procuring, and the varietal information had to be there. And you deploy all of these on the edge, so that you don't need an internet connection to operate. And then once the data is collected, you have a reporting layer which is giving in you data on what is the way out, right? What is the current status? How many tons have been procured? How many farmers have been impacted? So we did the solutioning story. We fixed the sensing layer first, which is, this device was used the for the Visio box, which was used for sensing the chili pods, physical one. We used a mobile phone because everybody today has a mobile phone with a decent RAM, right? Good enough and a good camera, and we deployed the model on it. Offline inferencing worked like charm. This is what we implemented. The device, along with the NIR device, and the mobile and the moisture meter, was on the field. And I'll actually show you this is the best part, right? This is where we deployed the solution offline. This is a on-field deployment. I'll just take a minute and show you this video. So, you know, this solution was deployed, and worked with Digital Greens on this project. This is the impact that they have spoken about in the in the report that they had submitted in the World Economic Forum blog. Um, and these are videos of farmers who are actually seeing things happening. Right?
So, Subrat, we have to kind of
Yeah. I'm
we
done.
are
I'm done.
on the
I'm done.
session. So,
So it's and Mrs. Hit solution work well on the ground. Very
uh,
good project. Mrs. Where lot of varieties, the man versus machine issues, lightweight technology has its limitations. There are a lot more things to do. A lot of other things. So here I am, and thank you. If there are any questions.
so thanks a lot, Subrat.